All right, well, we can get started, at least with introductions and some just a few tips. So I'm Caleb Lenhoff. I'm the engineer channel manager here at Airflow. Sort of took over for Dave Madsen. He was our engineering manager for a few years. He's now focusing on sales. We wanted to put in a position in place where we could focus more on engineers. So if you haven't heard from me, you'll be hearing from me soon. I've been in the position for 10 months now. We're still kind of figuring it out. Anyway, thank you all for coming. A couple logistics things before we get started. If you do have to go to the bathroom, since we have one of our largest groups, maybe some people haven't been here before, right through that door around the elevators, there's a couple bathrooms right there. To introduce you to today's speaker, Dave Madsen. He's a PE. He has 28 years experience in the HVAC industry. He's been with Airflow for about 5 years. Like I said, part of that, he was the engineering manager. But he is our dust collection expert here at Airflow. So we thought it'd be a good idea to have him do this training, which is all about dust collection safety. So I don't think I have anything else. And without further ado, thanks, Dave. Take it away. Again, thanks for coming.
Yeah, thanks for coming, everybody. This is will be one of our better attended classes. I think we're up to 40 online, I think you said, Mike, right? We got a bunch online, we got a bunch in person here. We're gonna go through dust collectors, a little bit about what they are. We're gonna talk a little bit about the safeties involved with dust collectors. And then afterwards, we're gonna have one of our manufacturers, Imperial Systems, run through a live demo in their warehouse of a collector that they have. And everyone that's online will be able to actually see it. And then the rest of us catch lunch. And then on our way out, we can stop and see the collector you guys all passed on the way in. We can open the collector up, look at the filters, see the safeties that we'll talk about today, and kind of get a feel and magnitude and size and what's involved with going in the collectors. So we'll start off with the dust collection love story. We always like to start off with a story in our presentations. Vanessa, the vacuum cleaner, could be Victor, falls in love with Gary the grenade. Could be Gina. So stick with us here. They get married. Vanessa and Gary get married. And their love child is twins. Everybody loves twins, right? We could have put a picture of Tom and his brother up here as well, as you know Tom and his brother. But let's get a little bit more serious. So when you're talking about dust collection, you're talking about explosivity, you have to look at it from a life-threatening standpoint, like we're the bomb squad. So you have a clear and present threat to the building and life. You have to analyze the device and the situation and see what's all involved with it, what do you need to do to correct it, and then take action necessary to reduce that threat level. And then once that's done and you've got it all taken care of, you can resume your normal daily activities. So we analyze the collector. This could be any collector. This happens to be a cartridge collector. You have on your inlet side coming in, you have to stop an explosion from going that way. You have the collector body. You have to contain and direct the explosion. So when it happens, you dictate what happens to that pressure ball and flame ball. And you have to protect the clean air side from the explosion itself going back into the building or outside and affecting people or objects. And how can we do that? We can actually minimize the chance of an explosion and a fire in our collector by stopping sparks or anything coming in. So if you have a wood system, you might have a metal spark, a nail head that pops off and slides through, creates a spark inside the ductwork that goes in. That could ignite a fire and explosion. So we have mitigating devices we can put in, such as spark detect and extinguish. We have an EIV, which is going to catch an explosion coming back into the building. And spark sensors that we can put in place as safeties to monitor and let us know what that's happening. Can we slide that on? Talking about the different dust collectors that are out there. Just a quick brief overview on which dust collectors are out there. On a Cyclone, you have no compressed air. Cyclone will just take the air into it and use the centrifugal force to remove it. You can return it, but you still have IDA, which is inline deflagration arrestor. Return air, you can definitely return air directly out of a cyclone, but your very fine, smaller micron dust is going to get picked up in that clean air side and put back into your building. So after filters are recommended. Filter efficiency when you're looking at microns versus a MERV rating of sorts through a cyclone is low. And nice thing with a cyclone, very minimal moving parts, very minimal filter. There's no filters, nothing that needs to be replaced. On a shaker, sometimes a cyclone and a shaker will be combined together. A shaker has no compressed air, uses a mechanical arm or a device that shakes the bags themselves off to clean them. Also requires IDA. Pretty much anything returning to the space has to stop that deflagration from going back into the building. You can return it, not a problem coming off a shaker for return. Filter efficiency, medium. You can get real expensive and put some real expensive filters in. They catch everything, which means you change them more often. And the filtering cleaning devices, like I said, by the mechanical arm. Cartridge collector, which is what we'll see later in the presentation, and we'll see it outside. We've got a sample. Does use compressed air, uses a pulse cleaning device that'll actually blow a pressure ball of compressed air inside the clean air side of the filter and shake the dust off. Then it falls off into the bottom in the hopper. It has integral IDA, so Imperial is one of the few manufacturers, maybe the only one, that actually has their filters tested for an inline deflagration arrestor device. So there's no secondary device required to stop that flame and pressure ball from going back into the building. You can return it, MERV 15, MERV 16 equivalent filters, and on-demand control for the compressed air. So it's only going to pulse when the pressure differential reaches a certain point that it climbs enough to clean it off. Bag house, compressed air, yes. Requires IDA, just like the rest of them if you're returning it. Filtered air the return air is filtered. Efficiency is high in a bag house. You'll see bag houses a lot of times in industrial applications where you have a lot more air and a lot more contaminants that are smaller that you need to filter out. And it also has on-demand compressed air as that pressure differential changes. Reverse air, not compressed air. You'll see that it actually has an air itself, a blower itself that'll actually clean it off. Requires IDA. It is filtered, medium efficiency, and there's a rotating blower that goes on it. And we'll see that in the next couple slides. Wet scrubber is, if anyone's used a wet scrubber before, the maintenance on a wet scrubber is high. Only because you get your water, you got to treat your water, send it back through. You can return the air off of a wet scrubber. Sometimes they'll send them through a mist elimination pad or a mesh pad to get as much of the droplets out. Sometimes they'll dry it, send it back through. Filter efficiency can be high when it's used for the right dust. A wet scrubber, wet collector is very efficient. And then cleaning is through quenching it with water. So what does a cyclone look like? Cyclone on the side is one of them that we have. It'll take the dirty inlet air through the side of it, send it through in a cyclonic measure going through the cyclone itself. The heavier, more dense particles will fall to the outside through centrifugal force and then fall down into the hopper or cabinet drum at the bottom. Clean air will go up through the inlet and back out into the space. A shaker will do the same type of system. So the dirty air is going to come in through the shaker. It'll have a little drop out here. There's an instantaneous drop in pressure in that as the velocity drops out. The heavier particulate will fall through down into the collection. The lighter particulate that still stays friable in the air will come up and get picked up by the filters, and the clean air comes out. In this scenario, there is a plate or an arm or a device in here that will actually shake, called shaker. It'll actually shake itself, and that's what shakes all of the particulate that stays in that filter media and drops it out. So it's self-cleaning. Shaker, like a cartridge pulse, is a self-cleaning device. Cartridge collector, no moving parts in it. That's one of the nicest things about a cartridge. Dirty air will come in, flow in through Usually there'll be a set of baffles in here that stops it from actually hitting the filters direct. It'll come through the filters, heavy particulate will drop out, your sediment falls out, lighter stuff will get picked up by the high efficiency filters. This is a septum plate, your clean air side, so your dirty air comes through, clean air comes up and goes out. These are your nozzles. The nozzles itself are what actually cleans it, pulse cleans the filters off. So there'll be a solenoid valve that controls that nozzle. That solenoid valve will get a signal saying my pressure differential between my clean air side and my dirty air side has climbed to a point that I need to clean my filters. It'll pulse off, send a cannon of air through that inside of that filter and blow the dust off on the outside. Dust will fall off, pressure will drop, cycle starts over again. Bag house, again, used for some larger CFMs. Dirty air will come in, same kind of concept as the other ones. You'll have your column of bags. A lot of times these bags will be in cages. They'll have supporting rings around them so they don't collapse. Clean air will go through and come out. The clean air that comes in on a bag house usually is either a compressed air that'll blow off the bags itself, or a blower that'll actually reverse that air back down and actually purge that air back into the bottom. Much bigger CFM. When you get into this stuff, you're getting into some industrial devices. Reverse air dust collector. Again, same kind of concept. It's got a series of filters that are in it. The dirty air will come in. It'll go through these. Sometimes they're even 4-inch diameter filters. Large particulate drops out. Smaller dust will get picked up by the filters. And then this arm is a radial arm that actually spins and rotates in a circle with a blower, and it actually blows the air back into the bags and pushes it out. Wet scrubber, same type of theory. Your dirt will come in. Sometimes it's in the form of a gas, where you want to actually wash the gas, keep it from being ejected out, or particulate. This particular wet scrubber, there's multiple different ones. There's a packed bed scrubber, there's a sump-based scrubber. It'll come through a series of either packed media or through a sump where it forces the particulate to hit the water itself or a spray nozzle, which will wash the air. And in theory, all of this stuff drops out the bottom, and clean air, clean moist air comes out. It's going to be high humidity. So basically sending it through a mist. And then when it comes out of there, and it'll be in a vaporized form, but you'll want to find a way to mitigate that moisture if you're going to put it back in your building. Now we'll get into the safety devices itself. We'll go through combustible dust. What is a combustible dust? We'll try and make that quick and not as boring and as detailed as it could be. We'll determine the combustibility and the classification of your dust. We'll go through combustible dust protection items. What do you need to do in the event you have combustible dust, and what options are available? And we'll run through some examples. As we go through this, as we progress through this, there's two things to remember. In dust collection, when you're talking about stopping a deflagration or an explosion, that's a completely separate set of devices, as is fire suppression or fire prevention. In dust collection, you can have a fire without having an explosion. You can also have an explosion without having a fire, or you can have both. So there's two completely separate entities to look at, and we'll walk through each one of them here and try and explain it a little bit. Definition of a combustible dust: solid material composed of distinct particles. Basically, it's anything that can be anything at all. Combustible dust is anything that can be ignited or started on fire, and it'll have an increase in pressure, and it'll have an increase in explosivity as it goes through, the pressure ball goes through. There's probably 12 or 14 NFPA codes that are applicable when you're talking about dust, depending on the facility that you're in. Is it a chemical? Is it aluminum? Is it wood? We'll get in, screw that up. We'll get in a little bit more about NFPA in the future. So what's happening with NFPA, all 14 of those NFPA standards, all 14 of them are going to be combined into one standard. And that one standard, I believe, is going to be called NFPA 660. And they're working through it right now. And NFPA 660 is due out in some form for review sometime late of 2024. So what we'll do with that is we'll we'll drop another training session on to go through just the changes that occurred in NFPA 660. Because NFPA in itself is exactly what governs a lot of what we do. There's, in most cases, the NFPA is not necessarily a code or a requirement that you have to follow, but the authority that has jurisdiction on that site, that building, the AHJ, more oftentimes than not, could be your insurance agent, trying to protect and mitigate their exposure to any kind of issues. Could be the safety director at the place, could be a code official, could be a fire marshal. Whatever it is, they will follow and make you adhere to the NFPA standards when you go through it. So more to come on NFPA. Typical dust, you can have a wood shop dust, dust which is a mix of cutting and sanding. The finer the dust, the more explosive it is. The bigger the chip, the less explosive it is. Machine shop, where you have grinding occurring. You can have a buffing system in a machine shop. When you're buffing aluminum, extremely explosive. If you're buffing carbon steel, still explosive, maybe not quite as much. Weld shop fumes and automotive shop fumes, both can be explosive. We don't know. There's really only one way to find out if your dust is explosive or not, and that's get it tested. It is a very inexpensive test in practicality reasons. It's probably $300 to $500, depending on how much dust and the type of dust and the number of tests that they have. Fike will do it for you. We can get you all the information you need to send it in. Your owner, whoever's on site, whoever's the maintenance guy, actually needs to go grab a baggie, just put it in a sandwich baggie of dust, label it, mail it into Fike with the check. They probably all do it online now. And they'll actually test it for you, and you'll get two numbers back, the two most important numbers that you can get. The KST, which the KST is the speed at which that explosion will propagate. So how fast that explosion leaves that collector and goes into or backwards through your dirty duct, leaves and goes through your discharge into your collection drum, or it goes through your collector down to your cleaner side, whether that's returning to your building or outside. And the Pmax is the pressure that's created during it. So how big is the pressure of that explosion? So you got KST as the speed, Pmax is the pressure, how big it is. So you have to get it tested. That's the big thing that has to happen. There's charts, there's standards. We have a lot of stuff that'll give you a basic general idea to start from. But a lot of times you might have multiple materials and metal that are occurring. So you're buffing, you're sanding, you're grinding, you're chipping, all that stuff comes back to one collector. That mix of dust is probably not anything that shows up on a chart because each site is specific. So in front of you is what Imperial has put together as an explosive dust roadmap. Those of you that are online, I think we dropped it in the chat for you, so you can download the PDF from there. Not gonna spend a whole lot of time on this, but one thing to note at the top, it says, has your dust been tested? And pretty simple, if it's a no, it's get it tested, and then you can start all over again. There's different dust classes. There's STO, which would be a KST of 0. There's ST1, which is your KST up to 199. And a KST2, which is between 200 and 300, and a KST of 300 or above. A lot of this stuff, if you look at it, underneath on the dust hazard analysis, right underneath the orange bar that goes the full side back and forth, the KSTs are all listed in 4 columns underneath of there. ST1, ST2, and ST3. It'll give you what you need to do on your inlet for protection. It'll give you your dust collector protection. It'll run through what discharge is required. And then on your outlet side, whether you're returning air to the space or not returning air to the space, or in some cases, your KST could be high enough that you're not allowed to return air to the space. So this is a good, keep it at your hand when you're doing dust collection, share it with your owners, share it with the people that you're working with to make the decisions. The architects that don't believe that dust is explosive. Non-combustible dust. There's only one way that anyone here can determine if your dust is not combustible, and that's to get it tested. If you have a KST of 0 and you assume that you have a KST of 0, or your owner is telling you, hey, we've had this dust, we've been doing this for 50 years or 100 years, we've never had a problem, it must be non-explosive, get it tested. They will actually take the dust, they grind it up, they throw it into a pressure chamber, they throw it across the hot wire that ignites it, and you will actually get a rating. And if it doesn't explode, you'll get a KST of 0. If it does, you could have a KST of 2. If your KST is that small, it's explosive. You have to follow ST1 class safeties. Typical dust that would and could come back as a KST of 0 would be silica, sand. We've seen some welding fumes on just standard black iron welding come back at a 0, and most vehicle exhaust fumes come back as not combustible. Kind of a little busy picture here, but we're gonna run through. So you have a couple of different things. You have your inlet. So this is your dirty air coming from your process, carrying all of your dust. It's gonna go into your collector. This happens to be the C-Max cartridge collector, but it could be a Cyclone, could be a Baghouse. That filtering device is gonna drop out through the discharge, your sediment particulate, into a collection device of some type. This is a collection drum, in this case, 55-gallon drum. You're gonna have your clean air come through your filters, through your fan. Fan's always on the clean air side, 99% of the time, and come through this way, and either your clean air is gonna return to the space or your clean air is gonna go to the outside. Typical dust collection setup that you would see on most jobs. If your dust comes back with a KST of anything above 0, you need inlet protection. On your inlet protection, you can have multiple devices depending on the KST you have, and we'll also lay it on the chart that you have in front of you. You can have an EIV, which is an explosion isolation valve. You could have a fast acting slide gate, or you could have a chemical boom of some type that actually will put a pressure back in and stop the explosion from going back in. You have the collector itself. In the event that an explosion occurs in the collector, you want to control where that explosion goes. If you don't have a sacrificial piece of metal or an explosion panel that will break away and direct where that goes, this whole collector could break up into a bunch of small pieces and actually become shrapnel and go all over. You have no control over it. So locating where this goes, the direction this faces in relationship to buildings, walkways, or other objects, trees, makes a big difference when you go through your design. Your discharge is off the bottom again, sediment comes out. If an explosion occurs in here, you have to stop this from becoming a projectile when that pressure goes down and into that collection drum. A lot of times you'll see on a non-explosive dust, that'll just be a little short section of vinyl flex, a couple of pipe clamps holding it on. That doesn't qualify for stopping an explosion going off the bottom. You need a rotary airlock, you need a Rhino Drum, you need some type of an enclosed conveyor, something that'll stop where you don't have a direct line for that explosion going back through there. And then on your return side, you need a clean air protection. So if you're gonna return it to the space, you need an abort gate. Abort gate is not an explosion protection device. An abort gate is the fire protection, fire prevention, smoke prevention device that's on there. So all the abort gate does, and the only reason it's not an explosion protection device, it does not operate fast enough to stop that propagated flame ball from going back into the building. So on the clean air side, this is the fire suppression, fire prevention device that just aborts the smoke if a fire occurs in your collector. The explosion protection part of it is your inline deflagration arrestor. That's either in your integral to your filters, like Imperial has, so they've tested them to stop that flame ball from going through, or it's a secondary device of some type in your clean air side that'll actually stop that flame ball. It actually extinguishes the flame itself. Doesn't stop the pressure from going through. The pressure's still allowed to go through. It'll knock it down a little bit, but the pressure blast is allowed to go through. It stops the actual flame from going back into the building. And what makes that important is when you hear about a collector explosion or a collector fire, most of the devastation that occurs, if there's any injuries or any life lost, it's not the initial explosion that gets anything. Usually these are outside, usually they're located in a space that's fine and nobody's working directly around them. It's that explosion that occurs here, and if there's no protection device going back into the building, it's that secondary explosion that occurs. So most facilities that have dust in them will have dust located on the bottom of the trusses, will have dust located on ductwork, conduit, whatever is in there. what happens in an explosion is the flame ball goes through first. So the flame ball goes into the building first. And it'll shake everything. When it shakes everything, all that dust that was sitting all up on top of any horizontal surface in there starts to fall through. And then guess what follows that pressure coming through? It's the flame. And now the flame hits all that dust that is now in the air. And it just goes up. So one way to think of it is you could have a pile of sawdust sitting on the table here. You could take a lighter and light that pile of sawdust and it would start on fire. It would probably burn. If I picked that sawdust up, held it over a flame like this and just sprinkled it down, it would just go because it's friable. It's going to burn a lot easier once it's in small particulate in the air versus in a pile. So we'll run through this. So combustible dust protection items. You have inlet protection, your dirty air side. You have to protect it from explosion. You also have to protect it on the fire prevention side. You'll have your collector body itself. The protection of the collector, you'll have fire prevention, which will be sprinkler heads. Some insurance companies will mandate that you put a sprinkler head in it, even if it sits outside. Some will tell you they want a certain distance away from the building in the event that a fire does occur, that it doesn't affect the building itself. And you'll have your explosion protection. On your discharge, discharge is down at the bottom. You'll have explosion protection. We don't have to deal with fire prevention in here unless you're enclosing this and running some type of conveyor or a screw conveyor of some type that's taking the dust to a different collection point. And then on your return air side, you'll have your fire prevention and you'll have your explosion protection. For your inlet protection, this is an EIV, explosion isolation valve. What it does is it stops the back pressure and closes off as that back pressure comes through to stop the flame ball from going back into the space. It's probably the most cost-effective way to stop it. And it only applies for certain KSTs on here. So when you get into a KST above 300, I believe, an EIV won't work. You'll have to get into some other type of device, whether chemical or a fast-acting slide gate. Chemical isolation is another one, and fast-acting slide gate. So that will go in this picture. It's kind of hard to see. In this picture, it's located right here on the inlet. Your dirty air comes in, your arm, as your dirty air is coming through, this is just a weighted damper, similar to a backdraft damper technology. The air comes through here, damper will open, clean it, dirty air will come through here. As that explosion occurs, this is going to close. One thing to note, because the explosion is allowed to come from a collector back to the EIV device itself, your ductwork from that collector to the EIV, that distance that's in between there, needs to match the PRAD rating of your collector. You don't want this section of ductwork to become the weakest point in the system and your collector to be protected and the EIV to stop it from going back into the building, but your ductwork to blow apart. It's an uncontrolled point where the explosion will leave that system. Usually that is, well, the ductwork between 12 gauge and 10 gauge, but that's a calculation you do based on what your PRAD rating is on your system, your collector. Here's a little, here we go. Perfect, nice work. So if you kind of see it in slow motion here, you'll see the pressure wave come through first. That closes it. The pressure wave closes it and it stops the flame ball from coming through. Pressure is going to travel first before the flame comes through. Another device we talked about was the fast-acting slide gate. Has the higher initial cost because it's also rated for a little bit higher KST. It will require some type of control to it, whether that's air or electric to activate it. On the collector side, so now we're going to talk about the body of the collector itself, how to protect that. You have an explosion vent, which is going to direct the explosion, control the explosion, tell it where to go, dictate how we handle that. Fire suppression, which is going to stop the fire that's inside of there, because you can have a fire without it exploding. Again, a lot of times fires will happen after the collector's been shut down, after dust is going through the collector has stopped, but you still have your pile of dust that's collected in the bottom. Spark may have been sitting in there smoldering, and then that's what starts the fire. And then another way to do it is to just put an explosion suppression chemical system on it. A lot of times you don't have wet sprinkler lines in buildings, or no one wants to deal with trying to put a wet sprinkler line to a collector that sits outside and all the safeties that are involved with protecting it from freezing. So we'll put chemical suppression on it. So on the body of the collector, you'll end up with that sacrificial piece of metal rated for the P-max of the collector and the KST of the collector. And you'll direct it. This, I wish I could have gotten this video to play, but it's too big of a file. This is a snapshot picture of what actually happens when an explosion occurs in a collector. And that's just, all this is from Fike's facility testing this sacrificial piece itself. And you can see that's coming off a fair distance away, and it's a flame ball. So anything that's in that direction, anything that's over there, whether it's a building, people exiting the building on a walkway, a tree, anything that's combustible, we need to make sure we control which direction that goes in. There's also a device that you can get that'll mount on here. There's two different devices. One device would be just an angled baffle, and it's rated to hold the pressure of the blast, but it'll just sit on the outside of that, and it'll take that flame ball and direct it up and away. So if you're looking at protecting a walkway, or you're looking at protecting an egress path, it'll direct it up and out of the way of the people leaving. There's also a actual plenum that you can get that's constructed the same way as the collector is from the collector manufacturer. The plenum will sit on here, and this actual device will sit up in the horizontal, and it'll direct it straight up and away. More expensive than just a deflector plate, but a lot more effective at directing and controlling where that blast goes. Another way to mitigate on the suppression side to stop a fire and explosion from happening is to put in a spark trap. Spark trap itself will minimize any sparks going into it, and what it does is it takes the spark itself, runs it through a series of baffles and plates, and it actually fractures the spark, the size of the spark down to a smaller piece, and then extinguishes it as it goes through. It's basically like if you're sitting around a campfire and an ember pops out and everyone takes the poker and you knock the ember down and you keep hitting it enough times and it extinguishes itself and puts it out. That's basically what a spark trap does. You're knocking it down to smaller pieces. And we have one outside on the trailer we can go look at on your way out. The other one is a spark detect and extinguish. And what this does is this takes a set of eyes located in your duct that sense a spark coming through. When it senses that spark coming through, it's going to send a signal to the control panel. The control panel is going to recognize that it saw a spark. It's going to send a signal to your deluge valve, and your valve itself is going to open, and it's going to spray mist in that duct to extinguish that spark. And then it's going to shut itself off. One thing to note on this is this water is usually a non-potable connection somewhere in the system. It is not connected to your fire suppression system, because this could go off 6, 8, 10, 12, 14 times a day. And every time this goes off, it's going to start the flow of water. If you're connected to your fire suppression, you're going to get an alarm every time it goes off. So keep that separate from your suppression. You can monitor this. Any sparks can be monitored and pulled back to any BACnet DVC system through that control panel. You can go up to it and see how many times it's happened, how many devices, how many instances this is one off to stop the spark. Here's a little video on kind of how it works here. So this is Graycon's kind of the pictorial. One or two sensors get installed on either side of the duct. And all it is basically like a photo eye. It's just picking up a light source coming through your duct. So making sure your duct is sealed, the light is important. It'll sense a spark as it goes through the eye. It'll send a signal to the control panel. Control panel will recognize it's got a spark coming through, and it sends a signal to the valves. Open up. And the valves will open, throw its mist, extinguish it, and then go back off. A lot of that gets set up during startup, because you'll have how long that valve needs to stay open for to extinguish the dust itself. But the more important thing is on the install side, that distance between the photo eyes, your Graycon spark sensors, and where your valve is calculated by the feet per minute going through your duct. So you'll need to know how fast, what's your conveyance speed, what are you picking up through your ductwork in your feet per minute, that velocity. And that velocity itself is what's going to dictate how long it takes for the signal to get from that sensor to the control panel, from the control panel to the valve, from the valve to open up. So it's picking that spark up, and it gives it a good plus or minus as that spark comes through to extinguish it. So that's a calculation. Everyone's a little differently. Every control panel is a little different. We've put in the PyroGuard panel before, and it's right in their manual, and it'll explain how to calculate it and what that distance needs to be. If anyone has questions on that, we can help out going through it. Another way to look at the collector body and protection is through chemical suppression. So you have, the reason a lot of people don't go with chemical suppression is because the high initial cost, the high replacement costs. And if you get a nuisance trip, the nuisance trip is a little expensive to come through and clean up and recharge. Usually you're testing your AHJ, your insurance company, fire marshal may require that you do routine testing on it, whether that's every 6 months, year, or biannually. And a lot of the devices will have if it's an ABC type fire extinguisher that's put on it with chemical in it, it may have an expiration date on it. So you may have to routinely replace that and get somebody in there to do it. On the discharge, we're going to talk about the discharge coming off the bottom right here. So that has to be protected. And there's two more common ways of doing it. One would be using a cast rotary airlock, an NFPA approved cast rotary airlock, or a Rhino Drum. The cast rotary airlock on the inside of it has no direct line of sight from the discharge hopper into the drum itself. So that will stop any explosion coming through. And if you haven't seen the inside of a rotary airlock, it's just a series of baffles and a star, and they just rotate. Picks the dust up at the top, rotates through, and dumps the dust out on the bottom side. But it's always sealed from the hopper to the drum. The Rhino Drum is completely the opposite. This is a wide open, free flowing chute straight down. No maintenance, no moving parts, no electrical, no controls. The key is you have to keep these drums with it. These are not a standard 55-gallon drum. They're a thicker drum. They're actually tested to hold back the pressure of an explosion itself with this coupling device on it. When you go to change these, there's a slide gate that you can close. So you can continue to run, your dust collector can continue to operate. You can close your slide gate, change your drum out, dump it, come back, put it right back online. And again, Rhino Drum is only good up to a certain KST. They only test it up to, I think, a 185 or a 190 KST. Once you get above that, it's going to throw you into a device like a cast rotary airlock. Their NFPA, cast rotary airlocks have to be NFPA compliant. There's a lot of rotary airlocks out there on the market right now. Not all of them are tested by NFPA. And the reason they get tested to NFPA, as those fluids turn inside of your rotary airlock, the tolerance between the blade and the sidewall as it rotates, you have to keep a certain tolerance to protect that explosion and pressure flame from coming back into the device at the bottom. It does require power, it requires controls, and requires routine maintenance. The Rhino Drum, again, it is tested by NFPA. They've went through it, no electrical, no maintenance, and no tools. They're all hand. These are little T-lock handles on here. You You can open them and close them by hand. You can change all of this by hand. We actually have a little shorty version of the Rhino Drum on the trailer we can look at later. All right, on your exhaust, on your return side, the clean air side, not the discharge. Remember, discharge is down here. So clean air coming back into your building. You have the abort gate. The abort gate itself will stop smoke from going through back into the space. You only need an abort gate if you're returning the air to the space. There's no other reason to put an abort gate in if you're just going to blow it outside in the atmosphere. You need your inline deflagration arrestor if you're going to return the air to the space. That stops that flame from going back into the space, causing that secondary explosion. You can put chemical isolation on it. You can put a chemical boom. Those chemical booms will sit on top of the ductwork and put pressure back in. Or you can do a two-way isolation valve. There's a manufacturer that makes them, Boss. They're called the Vigiflap or the EIV. Both can be used on inlet and exhaust. And both are rated for to stop the explosion on the EIV side. So here's a picture of a abort gate. Your clean air will come into your abort gate. And it has a very large, heavy plate that's held up with magnets. And under normal operation, power's on the magnets, holds the device open, air is allowed to return to the space. When it activates, this is also controlled via spark sensor, but right next to the collector, there's also a distance, ironically, right? Spark sensor for when it actually sends a signal to the abort gate. There's a distance there that you have to be within to make sure that it gives that spark sensor enough time to make it through the control sequence back to the abort gate to shut down. Again, they do require spark detection for activation. If you're dealing with wood dust, again, NFPA standards are all going to change and get combined into one. Currently, if you have a wood dust facility, it's mandatory that if you're above 5,000 CFM and you're returning the air to the space, you need to use an abort gate. And that's because you can have a fire without having an explosion. So you got to have a way to get that smoke outside of the space rather than back into the building. Here's a little video of the inside of the abort gate itself. Clean air going back in. And this is where the abort would take place. Sensor. So again, that distance between the sensor and the abort gate is key based on your velocity in that duct. Control panel will be mounted on the side of the abort gate. To arm it, you'll hit the raise gate button and hold it. And set a cylinder will set that abort gate up and hit the magnets. So these are just two plates. The magnets will sit up here. When it's up, there'll be a proximity switch mounted on the side of it. It'll tell the system, I'm in the arm position, I'm up. Then that red light will switch to green and you'll be good. And then when the spark is seen, it actually cuts power to the magnets. So it'll cut power to the magnets, some catastrophic thing happens, the magnets will lose power and the plate will drop. So that camera was on a tripod, probably sitting about 10 feet away, and you can see how the camera actually shook. That's a heavy plate. That's a heavy device. If you're going to hang it up in the air, it almost more times than not are going to need its own support, whether it's a quad stand or a pipe support or something off the side of the building. But they're heavy, and when they go down, we test them. We test them when we do the startup. When they go off pretty loud. It's a pretty big bang. I clicked on something. Again, it's in the manual, it'll give you the distance from that spark sensor to the abort gate. And a little trick you can do is, because it's based on feet per minute, you're not worried about conveying dust at that point. It should be clean. If you're conveying dust there, we got bigger problems. But if you can slow that air down coming through there, you can shorten that distance in the amount of ductwork that you need. So the easiest way to do that is to blow your duct up, make your duct bigger at that point. Doesn't have to be welded, doesn't have to be anything fancy, just regular galvanized rubber pressure class. The system is 8-inch, 10-inch. That's all it has to be on that side of it. But it'll take that velocity down and shorten your distance up. Otherwise, you see like the one picture here, they didn't have the distance from the spark sensor, which was located right, actually there's a spark sensor right there. They needed to get that distance from here over, so they actually had to create this U to come in. If this stuff would have been larger, you know, based on the calculation, we might have been able to get rid of some of this and go straight in. But it's all based on that feet per minute through that system. Inline deflagration arrestor. So what the IDA does, the IDA certification stops this explosion from going back in the clean air side, from the dirtier side to the clean air side. It's going to contain it at the filters, at the cartridge filters itself. Again, Imperial has their filter tested for this, so it doesn't need a secondary device on the top. IDA, what does the IDA do? Again, it arrests the explosion going through from the dirtier side to the cleaner side. It stops that flame front. So that flame front doesn't go back into the workplace, it doesn't go back into the building, it doesn't cause that secondary explosion when all that dust from the rattle happens. Again, only deals with the flame, does not deal with the pressure ball going through it. And it is a max KST of 185. So once you hit anything above 185, now you're dealing with a different method of controlling that deflagration going back into the space. That's a Vigiflap, that's an EIV, it's a fast acting slide gate. Some manufacturers have not tested their filters in their collectors, the IDA. So what they do is they will throw a secondary bank of filters on their collector. Secondary bank of filters usually is a HEPA filter. And what's kind of ironic is the HEPA filter itself is only 1 MeV above what most filters are in a cartridge anyways. So it's only going to pick up the very fine stuff that might come through. Couple reasons that we don't do this are adding a second set of HEPA filters on here is a very, very high pressure drop. High pressure drop means you gotta have more horsepower. More horsepower means it's gonna cost you more to run it. It is an increase in filter costs because now you're gonna have to replace these on a regular basis. If you get a tear in this for some reason or blow by, you're gonna end up collecting all of it into your HEPAs. Now you've got 2 sets of filters that you have to replace at a pretty hefty cost. It also adds installation costs because this whole module will come and you'll have to bolt that on and install the filters in it, and it creates a much, much taller unit for service. So now if you're only talking about putting a platform here to access this, now you've got a platform that someone's now got to put a step ladder on to access the HEPA filters. The option of not doing inline deflagration internal to the filters is to add a secondary device. This happens to be a small one, but what this does is it will actually take that flame ball, send it through a series of fine mesh filters and screening, and it actually knocks that flame ball down and allows the pressure to go through without the flame. It's pretty costly. When you're doing the schedule and you're looking at the schedule itself, there's a few key things to do when you're building your schedule, whether you're building it as a design build and you're going to turn it in for submittal, whether you're doing it as an engineer and you want to protect your butt from future, anything being connected in the future. Make sure you drop your KST on. So your dust KST. So when you design a collector, remember, first thing you do, I don't know what the KST is, get it tested, right? If it's a new facility, use one of the listed standards, because it'll get you protected. If it's wood dust, I have a KST of 150, it's a standard wood shop. If anyone comes back later down the road, tries to connect up a grinding system to it, maybe they're gonna do some buffing of aluminum and try and use the same collector, you're off the hook if anything happens. Because you've designed it to a KST set value on your schedule. Our collector, when it shows up on the tag, will also have the KST listed. So in the future, if somebody wants to come through and try and add on or pick up more points in their dust system, they've got to make sure, get the dust tested and make sure we stay below that KST level. Also drop in what your minimum conveyance velocity is. That is all tied to what your type of dust is. Lighter fumes will need a slower conveyance speed to be carried through the collector. Heavier wood dust, heavier metals will need a faster feet per minute to be carried back. Also, the efficiency of a cartridge collector, a shaker, anything that's got media in it, the efficiency of that collector is dictated by what your air to cloth ratio is. So the better you have your air to cloth ratio, the longer your filter life is going to be. And if you go with a less efficient filter and you're trying to put more air through the same square footage of media, you're probably gonna have to change your filters more often. But that also gives your customer the ability to say, I'm changing this out in the future. What do I need to do? Here's what we designed it to on the initial side. And then your static pressure. Everyone likes to put total static pressure on the schedules, totally fine. But total static in a lot of cases might not pick up the equipment itself. So we have to make sure we pick up, it's kind of hard to read over here, make sure we pick up the static pressure that's on there from the collector itself. Your initial filters through a media filter is going to start off somewhere around 0.1, 0.2, 0.25, your differential. But as that lowers, and it doesn't take long, you're going to load up to about 1 inch to 1.5 inches, and you could run at that for a very long time. If you have a shaker, if you have a pulse cleaning system with compressed air, it could actually hover around that 2-3 inch mark for quite a while. It'll climb to 4 to 5. A lot of times they'll tell you that you don't need to change at 5 inches. Order yourself some new filters, get them on hand. When you run to the point where your pulse cleaning can't clean off anymore and it can't drop that differential pressure, then that's the time when you want to go change your filters. So just a quick recap. You've got your inlet protection. Remember, we've had a couple different devices on the inlet side, EIV, spark trap, fast acting slide gate. On your collector itself, you're going to have your controlled explosion isolation device, which is your panel. You'll have your discharge protection, rotary airlock, Rhino Drum. You'll have your clean air side that comes through. So you'll have your abort gate. And then you'll have your inline deflagration control, which will either be your IDA filter certification or some secondary device. There we go. Biggest question we get. Hardest thing to handle is the very end of every single job. Every contractor wants to be done with it. Electrician wants to be done with it. Mechanical says my stuff's put in. Controls guy says it's not in my spec to control it. The biggest hiccup we have on every single dust collection job that we see, it's not the install, it's not the ductwork, it's not the equipment, it's the controls. It's who does the wiring, where does the wiring come back to, what terminal do I land it on, how do I control it, getting an error code here, how do I fix it? And the biggest thing we say is the field coordination between the trades should start right when POs are led. We will usually offer a couple of site visits and a couple of meetings just to get everybody on the same page. Make sure everybody knows what's 110 volt, what's 24 volt, where's the 460 volt 3-phase land, who controls that, who gets the VFD, how is the VFD controlled. I've got a building automation system in, I want to know how I tie in my controls to it. All that stuff we can talk about early, we can talk about it often. I think we have our service tech, Zach, right now. He's actually out on a school job in St. Francis. He's doing the startup, working with the controls guy and the mechanicals on it right now, getting that all buttoned up. So we're here to help, just ask questions. A couple pictures to close out here of some dust collectors. This is a great picture, it shows everything. Here's a wood dust AST less than 185. There's your explosion panel up high enough, directed away from the building. Your dirty air coming in, your EIV with the set distance from here to the collector, your abort gate on the clean air side, and your rotary airlock. Everything's protected. So a couple of these, this is also a wood dust system. All the safeties are in place. On the left, weld fume collector. They're not grinding, they're not doing buffing, they're not doing polishing, just strictly weld fume, no safeties. If you look close enough, you can see this is just that clear vinyl flex we talked about at the bottom, the 2 pipe clamps. No concern about the explosion coming through that. KST is 0. Indoor units, we've shown a lot of outdoor units in these slides. Here is an indoor unit, really hard to see, but this is an outside wall. And it's on spice system, it has a KST, so it's explosive. This is an outside wall right here, and this is where the explosion device is located, the explosion panel on the collector. You have a set distance that you can duct that to the outside. FIKE will rate that based, whoever manufactures that explosion panel, they'll rate that distance and tell you based off of that KST, based off of this panel, you have a set distance that you can run to get to atmosphere outside. This one in particular goes right outside. Here's another version of one where it goes up through the roof. So we have a set distance of what that can be going up through the roof. So collectors can be put indoors. There's just some safeties and additional steps that we have to take to do that. Weld fume, if you notice on here, no safeties again. AST is 0. Shot blast, we have our inlet protection. We have a spark trap. We have our explosion panel. We're venting it outside, so there's nothing here for an abort gate. Because we're not returning the air to the space. If we were returning the air to the space, we'd have to have inline deflagration protection and an abort gate. Paint dust, same thing. You got your devices on the bottom, just kind of showing your rotary airlocks. And we're gonna hold questions for a moment. We're gonna take about
I think we'll do a 10-minute break. And then we'll come back and we'll do a virtual walkthrough of a dust collector for us and people that are watching online. And then, yeah, then we'll have lunch and then we'll go look at the one outside. One thing I did forget to mention when I started, next month is our next training, October 10th. So that'll have to do with this electrification trend that we're seeing. So you're seeing more like heat recovery chillers, low water temps, and like how do you heat buildings using low water temps, especially buildings with lots of windows, that kind of thing. So it'll be some information about that and solutions that we can offer, different ways to do it. So keep an eye out for that, and hopefully you guys will attend that one too. So take 10 minutes and we'll see you guys back here at 10:10.
Oh, Dave, are we back on?
Yep, we're back on. All you.
Okay. All right. Well, sounds good. Sounds good. Thanks for everybody being on here. Dave, appreciate everything you shared with us earlier there. Guys, I'm gonna take a couple minutes here and kind of walk through what is our dust collector. It's a C-Max dust collector. Typically, we would have this up in our showroom, but we just came back from a large trade show called FabTech, and so we're still unpacking from that. But this is our flagship dust collector here at Imperial Systems. It's our C-Max, and we're just going to go through and show you guys a lot of the actual applications of what Dave went over through some slides, and walk you through how this is put together and how a dust collector works. Now, typically, this dust collector would be higher up in the air, would be on with a platform and a ladder with a barrel underneath it. But to show you guys, we just leave it down on the ground to make it easier to see how the filters go in and out, and just a little bit more about the unit. So Erin's here helping me out with the camera work, and she's going to follow me around, and I can show you through all the different aspects of it's going to be. Some of these features are just particular to our collector. A lot of them are in a lot of dust collectors. But let's start out with the way that the air will travel through the unit. So we're going to come around to the back side of the unit here. And what we're looking at here, this is where the air would enter into the unit. This is the inlet. On our unit, we have inlet baffles that helps disperse the air and protect the collector. On our unit, a couple of things you'll notice that are slightly different. You're going to see no bolt holes on the outside of this. The only bolt holes you see are actually sealed on the inside. This is a fully powder coated system. We have a domed roof on our system, or an arched roof, and that just helps with all types of weather and climate concerns. So fully powder coated. There's an access door here in case anything would ever get clogged up into the inlet baffles. At times, you never know what people are going to put into your dust collection system. A lot of the times it's things that you don't want in it and can get clogged there. So there's a way to access that. So now we're going to move around to the front of the unit. Up here is our cleaning system, but we're going to open the door and we're going to look at the internals or the guts of the C-Max. Our doors are equipped with a latch on the back here. It allows you to have a lockout tagout system if you need that for when you're doing when no one's accessing the collector. So this is the internals of a C-Max. This is actually what will the clean air plenum or the filters look like. So we're going to pull these out. A couple things you're going to notice that are a little bit different about our collector than other collectors is the rail system. The way that these filters go into a C-Max dust collector are slightly different than the way you'll see them in other collectors. So this is what we call a vertical style collector. The filters go in here, get loaded in vertically. There are other collectors on the market that are horizontal style collector. And that means that the filters will be sitting in this direction. They would go into it through a small door, typically on the front. And then the filters are stacked on top of each other like a ladder. So when those clean with the compressed air, there's compressed air that runs to this. When the collector senses that the filters are dirty enough through the pressure change, it pulses clean air down onto the filters. Now, in a horizontal style collector, it typically starts with the top one, and then it'll pulse down to the next one and pulse down to the next one. So you have a kind of a cascading effect with the cleaning, almost like a slinky going down the stairs. Each kind of the dust falls on top of the next filter. When you deal with a horizontal or with a vertical style filter, one of the things you're going to see is that as it cleans, all of the dust just goes straight down into the hopper. So that's a little bit of an advantage of this style of collector. You get a little bit of a bigger footprint, but if you're outdoors, that's not really that big of a concern for most people. And since it's fully powder coated with the arch roof, outdoor applications aren't a big deal. For us personally, we have a full lifetime warranty on the shell of this unit to say, we believe that the entire time this unit's installed, it'll be protected from the weather and you'll be good to go. When we look at our filter, this is a 400 square feet of media in this filter. So that's different than a lot of other filters that are out there. It's an important thing to think of whenever you get into sizing collectors, is the square footage of media really plays into how big that collector is going to be and how that collector performs. So when you are looking at different units, let's say you're looking at with some of your customers for multiple styles of collector, even though one collector may say it has 12 cartridges in it, and this other unit says it has 12 cartridges in it, it may not be apples to apples because the size of the filters could make a big difference in how that actually performs. If one collector only has 90 square feet of media per filter and ours has 400 square feet of media, well, 12 to 12 isn't the same. And the guys over at Airflow do a great job helping you figure out that. You guys don't have to know all of this information. The guys over there know a ton of it and are able to help guide you through what those different changes look like. Our filter has a double gasket on it. Now, a gasket is typical on most filters that you're getting a dust collector. Most of them only have a single gasket on it, mostly for economic reasons. Our filter has a double gasket on it. We just feel it's additional protection. It really helps to just make sure when you get into some aggressive dust that you're not going to get any pass through into the clean air side of this and back into your employees, back into your workspace. For us, very simple to load up our filters on here. I'm going to have Aaron come in a little closer to show you a couple features that are a little bit unique to ours. They might not be on everyone else's. Ours actually have these even lock lift rails. They cam all the way back evenly. And we have this shelf for the filters to go on and they get pulled up in. A lot of times in this style of collector, I'm actually going to pull the other filter out to show you what can happen is when you are loading these filters at times, what can happen is that as someone loads this one, if they tend to push on the bottom of this filter, it can get set on top of the other filter in that in the collector. So there's other styles of collectors out there that could be an issue. With ours, we have the ability to add a top channel onto this, which allows us not to be able to ramp that. It prevents it from happening because there's just enough room for the filter to go in. For some of your customers, another issue could be a confined space issue. If you break this barrier, sometimes that's an issue. For our collector, they come with a tool that allows you to remove these filters. So we don't have it on this because we just transported this back from our trade show. So apologize for not having it, but you can just simply slide these in, and then this one will just go right on, and also very simply slides in. Like I said, there are a couple things that set our collector apart from other collectors. Typically at this point, what can happen is people just decide they're done and they forget to actually engage the filters, actually lift this rail back up. When you lift this rail up, it forms that seal against the sheet, the tube sheet, and allows it to keep all the dirty air in this side of the collector, and then allows the clean air to come out through the top. If people, individuals, whoever is doing the maintenance on this forgets to engage this rail, it allows a space here, a gap, and then air can get by, and the dirty air is then going back into your shop. Typically, if we would see that, we would assume that a filter went bad or that they've just reached the end of their life. But if this happens, we've sent service techs out to try to help with that issue, and it's simply just lifting the rail up. Someone had forgot to do that. So for us, what we've done is we've added this tab onto our collector, and this prevents you from being able to shut the door unless the rails are actually engaged. So as you engage the rail, it slides past the front of the door, and it's just a safety precaution there that we've installed. I don't know if you noticed the unique shape of the pan of our filter, but one of the reasons it has that shape is because we have these indexing tabs, and you can see them here on the door. And this also, at times, people may not push the filter in all the way, engage it into its proper position, and that leaves the hole on the top. It leaves a gap, and air and dust and dirt can get by on that. So what we've done is we've built this pan in such a way that if it's not engaged in the correct place in the door cannot close. So those are just a couple safety features and benefits that are to ours. We also have no internal ledges on our collector, so when you open it up, it's not having any dust fall on the ground. That's important whenever you are trying to, just keep housekeeping to a minimum. We have a very heavy rated door. Like Dave was saying, it's been tested by third party for explosion rating. We have our header tank with a gauge. Typically, we want to run these at 90 PSI. So when you're talking to people, shop air is an important thing to know because these do consume shop air. So you might need to make sure the compressor is sized for the right size. You want to just take that into consideration whenever you're looking at a collector. This will require 33 SCFM at 90 PSI is what we try to hit each filter with. It's not going to consume that all the time. It's only going to consume it when the filters need cleaned. These can be designed to clean on demand, which means when the filters get dirty enough, they can clean. They'll clean automatically by measuring the pressure between the dirty side and the clean side. That would be through a timer board that cleans that, and a pressure gauge. You can also clean these what we call downtime cleaning, and that is typically when the shop shuts down or when a piece of equipment they're attached to turns off, and it cleans the filters at that time. It's really good. It just helps keep all the pressures at the right level and cleans whenever it's offline. I'm gonna have Aaron come around this side here. Now on this unit, it is available with a top mounted fan, which you can get up to 100 horsepower on ours. But then this is a side mounted fan option, or you could have a ductwork that comes down here. And so we can then look inside here. This is what the clean side of a dust collector looks like. It's you'll see that the pulse pipes and it blows down into the filters. And that's just a little bit of, typically you're not going to see that unless you are the person who has to crawl up in there for some reason, but nobody ever wants to do that. So just walking around here, this one does not have an explosion vent on it. If we did have an explosion vent on this collector, it would most likely be on this side of the collector. And like Dave was talking about earlier, that is just an important prevention device for when you get into those explosive dusts. And those are tricky. Dave talked about this also, about how you know when dust is explosive. One of the examples I always like to talk about is wood dust. Wood dust is an explosive dust. We know that. But there's a 2x4 that won't explode, and there's sawdust that will explode. And to know where you're at on that spectrum, you have to get it tested, because you're either closer to a 2x4 or you're closer to sawdust. And so that's just an important thing to take into consideration. So when you put the explosion panel on here, what it does is taking what Dave said is kind of a bomb, and we're making it into more of a directional device. So it's making it maybe a little bit more into a gun. And we're going to take that danger and we're going to aim it in a safe direction. So that's really it. They're not overly complicated machines with how they work. What gets complicated is knowing how to size them properly to make sure that all your safety features are in place and that everything is installed correctly and put in place. When they're done correctly, they work great and you forget about them. When they are not done correctly, it can be a potential risk or hazard to those that are around them. And that's really what we're just hoping to help you guys understand more of here. I might have went a little quicker than Dave was anticipating, but I'm glad to leave a little bit of extra time for questions if we have those. So,
Hey, Donovan, one quick
Dave,
thing.
you still with me?
Can you hear me?
I can hear you.
If you're located outside with that collector, can you kind of just point out where the solenoid heaters would be?
Yeah, so up here is our two types of this is the solenoid enclosure up here. So in colder climates, typically your air can kind of, if you have a little bit of moisture in your air, you may get these to get frozen up in the wintertime. And so there's a heating element that would get put into these solenoids up here. It's simply wired in to allow in colder climates to keep this running properly. We always recommend that you have clean, dry air coming into the compressor. So when you install this, if you're gonna be in a colder climate, which most of you guys up there are, unless you're speccing something out in Florida, I would always recommend that that's a great thing to add. It doesn't cost that much, but it saves a ton of just wear or maintenance, having to climb up on a ladder to try to just figure out what's going on here. So it's a very simple device that's going to help save a lot of headache in the winter times. Always try to put a filter prior to the air so that you guys can still try to maintain clean, dry air going into the collector. It's just a real simple thing also that helps with a lot of issues.
We would normally put a regulator with a filter dryer or desiccant dryer on the inlet side of it. Keep that air dry as we can and regulate it down to that 90 PSI and 33 SCFM.
Yep.
Anyone want to see anything more on the collector on the inside? Real quick, Donovan, can you go back into the clean air discharge and just show them those?
Yes.
The actual nozzles, talk a little bit about how it cleans it on the inside, where the air comes from.
No problem. So when you're looking at this, there's just a hole in the pipe, and that is adequate enough to allow the air to pulse down into here. Some collectors will have a nozzle on here. This collector, just because of the size and how it's set up, this is enough to clean this filter. That's all you need, is just just this hole to hit this filter hard enough to pulse it off.
But that distance and pressure that it is away from the inlet to the top of that filter, it'll create that cone and pressure and push it all the way down to the bottom of their filter, press all that, push all that air back out, shake it per se, shock it, kind of knock it out.
Yeah, exactly. It's very much like your shop vac at home where you take the filter out and you got to bang it against the wall. This one just has an internal self-cleaning mechanism that you push that air down through there. And much like the shock wave that we talked about when an explosion happens, the shock wave of the air goes down through and pulses the filter clean.
And the number of solenoid valves and tubes you have coming through is basically driven by the number of cartridges the collector has, correct?
It is. So once you get into a larger size of collector, we can clean 2 filters at one time, and this pulse valve goes up in size. But for this one, it's cleaning 1 filter individually, and each solenoid is associated with that. When you get into larger collectors, you can double up on it, and we put a larger pulse valve on there.
And the collector has the ports already on it. So when we talked about the differential pressure between your dirty air side and your clean air side, the ports are on the side. Those tubes will come back to the control panel, and that is what activates or controls when that on-demand pulsing takes place for the filters.
Exactly. That's how it works. When we talked about, that's how this style of collector works. Dave talked about earlier, touching on some other styles. There are some that just clean all the time. There are some that clean by shaking, clean by just blowing air down in. So when you start to look into for your customers and help advise them on what the different consumables will be, we know shop air can get expensive at times, especially if you purchase a collector that is constantly cleaning. So the monitoring and the differential pressure, whenever you're talking about a collector like the C-Max, allowing it to clean just when it needs to be cleaned and only down to when it's clean enough, can help save money in the long run. I don't even know if we didn't talk about, there's a lot of things up in your area in a lot of states. If you go with the VFD, which that'll help save money on things. A lot of times the state helps pay for some of that. Sometimes the power company helps pay for some of that. So programs like that, calculations on how much money you're going to save by going with the correct collector, Airflow is going to be able to help you guys out with that and find where that money savings can be for your customers.
And you mentioned, Patrick, the square footage of the cartridge is the amount of media that you need for your CFM. That's your air to cloth ratio.
Right.
And
right.
There's industry standards that you would want to follow that would be a recommendation or a starting point for what your air to cloth ratio should be for the type of dust you have. The main thing when you look at it is each cartridge by each manufacturer is a different square footage.
Right.
I think Imperial makes their own. They make all their own filters in-house. They bleed them up, they roll them. They put the cages inside. That's part of their testing for their IDA. And then that square footage, which is the square footage if you were to take that whole media and spread it all the way out, that square footage is what you use in your air to cloth ratio.
Right. And that's where, Dave, we talked about earlier about how when you're looking at different types of collectors, if a collector has 90 square foot of media in their filter and we have 400 in ours, it's going to take 4 of those filters to make up for one, about 4.5 actually. So when you're looking at different types of collectors, that cartridge count doesn't always equate apples to apples. And you got to make sure, like you're talking about, that air to cloth ratio is going to be on par with what you're trying to do. And there are industry standards that are out there. Weld fume has certain standards that people typically go by. Wood dust has certain standards that people go by. But there's always some exceptions to those rules. You can get into weld fume that's very sticky. You can get into wood dust that is very light or very chunky. And that's where guys like Airflow, who have the experience and have seen a lot of these different scenarios where it kind of is an exception to the rule or might break the rule, that's where you guys can really lean on their expertise to guide and direct you, where it might take a little bit extra than just what the book is calling out for.
You mentioned sticky dust, Donovan. What would you do in a cartridge collector if your dust was a little stickier? Do you have a bag that you can put over it, or how do you handle that?
Right. So, well, one is when we're talking, we can start to get into this. This could be probably a whole nother lesson on just types of filter media. You can get this is a fire resistant uh, nanofiber material that's on this filter. There's a variety of different types of media that the actual paper that these filters are made of. You can get a variety of different types. So you can get into a spun bond, you can get into a PTFE, you can get into like Dave was talking about, putting an over bag, another protective layer over this filter that goes into there. And so there's all these other options that are out there, and having someone who has that eye, having that experience with the dust, and being in that situation for years helps a lot in knowing what the right media is. Because when you start to get into different medias and different types of material, you can get into different size. This takes 400. You get into a PTFE filter, you're going to be in 245 square feet of media, which then totally changes what you're doing as far as the size of your collector, what you need, and kind of how things go together. So yeah, there's a whole nother section on just filters that we could learn here. We could do it. We could do an NFPA one of these. We could do a filter one of these. There's a lot of information that goes into a device that, I mean, it's going to take your dirty air out, and it's going to pull it through the filters and put clean air back in. The idea, the concept of it is simplistic, but the mechanics of it and making sure that you have it all done properly really, I think, takes some people who have been in the industry for a while and have experienced some of the trials and tribulations to prevent that happening to people who are maybe new into this or don't have as much experience and knowledge, especially a customer, maybe they're buying their first dust collector, or maybe there's an engineer on this that it's their first time ever designing this, working with the dust collector system. I know they don't come up every day. So people who do it every day have that knowledge. We're here, Imperial's here to be a resource, and I know Airflow's there to be a resource for you guys too. So.
And the cartridge collector this is the same size that we'll see on the trailer when we go outside. It's a 4 cartridge unit.
Correct.
If you have more CFM and you require a larger unit, these are modules. They come in modules of 4 or 2, and they just get added on at the factory built. They're still all welded together. They show up as one unit, unless you get big enough that we can't put it on a truck. And then it'll be field bolted together. So.
Yeah. Now, and if you guys are ever in Western Pennsylvania, we have an open door policy. Anytime we're open, we're more than glad to give anybody a tour of our facility. Also, our filter facility is just down the street. Everything's made here in America. We're an American-made, American-owned company, not far from you guys. So if something brings you through, please feel free. Reach out to Airflow, reach out to us. We'd be more than glad to show you through everything we got going on here.
Who's gonna do the Q&A?
Yeah. Any questions while we got Donovan on, either online or in person?
There's 3 of them.
Yeah, since we're here, there's a question about quality of air for compressed air. Does there need to be a certain quality requirement for compressed air being used inside of that?
Did you hear that? Catch that, Donovan?
It's a little choppy. I heard it was about the compressed air.
Yeah, anything.
How much is consumed in the header tank?
So we talked a little bit about putting a compressed air filter on it and a dryer. Is there any specific requirements as to how dry or how clean that air has to be, or any issues that you've seen?
No, we always recommend it to be as dry as you can. And I know that's just a term, but what can happen is if there is a drain in the tank, so you can check that if you need to. But what we have seen is if you get too much moisture in your shop air as it's coming out of the pulse pipes, that moist air can then start to get onto the filters, and a wet filter is going to not perform the way a dry filter does. And so we can start seeing issues within the filter as that moisture from the compressed air gets in there, and then it starts to degrade the filter, take the filter life down. It causes almost like a clumping, or depending on the nature of the dust, it can affect the filter, and it could cause it to not perform the way you want it to. So that's where an external factor such as shop air, wet shop air, can start to affect the life of of your filters. And so that's why we always recommend for a couple $100, you can put a dry air system in place, or a filter that we were talking about, and it's going to save you, possibly a lot of life on your filters, and nobody having to worry about that or go up and do the maintenance on it. So
This is like old temperature control pneumatic air that you needed, like you'd buy a little air compressor. Then you'd buy a little receiver dryer thing. There wasn't a lot of dough, but if you just add that to your shop air compressor with the separate line out, so you don't have to dry all your shop air.
Yep, exactly. And
Okay.
it's not, and most of the time you're gonna have, if you're a big industrial facility, you're gonna have a larger compressor or multiple compressors for standby. And you're gonna have a refrigerated dryer of some type. Because all your machinery is gonna wanna be as dry as it can be. It's gonna come out warm. And the key is when this air runs outside, you're gonna run 10 feet, 20 feet, however far away it is, might be sitting outside. You wanna make sure that that's as dry as you can get it going out there. So even though you've got piping through your facility, it's gonna leave your dryer in your compressor room dry. But it isn't always ensuring that it's nice and dry when it gets out there for the cost of a couple $100. It's only 33 SCFM, so it's not a big unit. Most of them are, depending on the size, it's a 1 inch or 1.5 inch diameter pipe running out to it. And the drier you can get it, the better it's gonna be. When moisture goes into the filters, it is, as Donovan said, it's terrible. Because all it's gonna do is, it's gonna embed and help embed that dust inside of the pleats, and it's not gonna be able to pulse itself off. It won't be able to clean, which shortens the life of your filters and then reduces your efficiency.
So follow-up question to filters getting wet, for the spark and extinguish system, when you do get a spark and that water turns on, does that make it to the filters? Can it make it to the filters? Cause you mentioned it may happen 12, 15 times a day. How, is that a big concern?
It can be, if it's happening a lot, yes, it absolutely can be. And if it's happening a lot, then you've got something else going on, right? You've got a process that's releasing metal or shavings or sparks are getting pulled up. You're collecting too close to a welding operation where the actual sparks from the weld are getting pulled through. And there's some mitigating things you can do on that. You can put a spark trap in right off of that device and trap that spark before it makes it into your system and out. You can move your pickup points further away from your collector and give it a chance to actually disperse that mist before it hits the filters and before it gets in.
Yeah, I can say something to that too, Dave. And I wanted to mention this too. I just had the opportunity to talk to Raycon recently. They are releasing a sensor that works in the light. So that's a great improvement on that system, that you don't get any false positives on that. So that's an improvement that Raycon's come out with. But the other thing is, a lot of times that Raycon system goes on a dust like a wood dust. And so when it's detecting that spark and it's spraying onto the dust. And so the spark is taking a lot more of that water before it gets a chance to get to the filter. And Graycon does they kind of know how far it needs to be away from the system too. So the nature of the dust that calls for a Graycon system is typically a dust that's going to take that water in with it also. It's going to help protect your filters in that nature. So on a metal dust, a lot of the times we don't quite need that system in place. Usually a spark trap like Dave was talking about or something along those lines can help handle it. So hopefully that helps answer that question.
Yeah, we have another question too. Is there a reason the support legs on the collector that was in the initial picture was not grouted? I guess we're trying to understand if it was done intentionally or if there's no particular reason for that.
A lot of the times when we have a grounding on this, there's like a grounding lug that's off to the side. Like our collector has it over here. I can show it to you.
Hey, Donovan, hold on one second before you go further. Different question, but this is a good point. I want you to keep going with this. The collector and the ductwork has to be grounded. We didn't really touch on that. We didn't talk about that a lot, but there's static that'll build up running through it. If you have a metal pipe system all the way through, as long as you don't have a section, some people will put a clear section of plexi or Lexon in there to see the actual dust coming through and make sure you're not getting any dropout. You have to ground across anything that isn't a continual ground all the way through your collector. And then the collector itself will have a grounding lug that the electrician must hook up to and actually sink a ground into the ground to actually ground it.
Right. Yeah. And the way our filters are designed with that tab system that helps to to ensure the filters are indexing correct. That pushes against the back. Everything is grounded and bonded within our system the way that the CMAX is designed. So
to answer the question that was actually asked in the chat is, in one of the previous pictures that I had showed on here, there was a collector that had the legs down to the ground that was mounted on a concrete slab, and between the plate, the base plate and the slab was not grouted. It probably was out on site a little too early and they didn't get a chance to grout it yet. But a lot of times they'll use some leveling nuts and washers to level the collector itself out and then come back and grout around that base plate. That's one of the things that our Zach, when he's out on site, that's one of the things Zach will check at startup and make sure that all that stuff's buttoned up.
What causes the static? Just the air moving across the
Friction, your dust running through your, just like if you're walking home and you kind of do this on the carpet and you go touch your brother and it zaps them and you laugh. Same principle is what's happening inside of the duct. You get your friction from your dust that builds up on the inside. And that static discharge is sometimes just enough to ignite or start a fire on that dust. You got one more in there, or is that the last one?
It was answered already.
Okay.
I got
Thanks. Yeah, go ahead.
one more. You kind of touched on the authority having jurisdiction, being the person that may enforce this or whatever. Like, is there a, like, who has the final say on what's installed, if it's installed correctly, or is it just completely up to the owner? Like, how is that regulated, if at all?
You want to take that one, Donovan?
What we have found most of the time that is going to have that final say is most likely the insurance company. They are the ones that are going to be looked at first if there is an incident. They're the ones who have to cover this piece of equipment if there is a fire within it or whatever. So, and they look at 90% of the time what the NFPA says to go with that. There are times in certain areas, if you get a job in California, it could be a lot of people who are going to have a say in it. Down to seismic loads and wind loads, even though you might be in a building. So, and that's where the government really weighs in hard on it. If you haven't had a chance to look at the Imperial sugar incident, that is really what kicked off a lot of these safety concerns. It's an interesting story to look up. And then from that, there's been a lot of regulatory bodies that have come in place to try to make a healthier and safer work environment. But that's where the NFPA standards came from. Like we talked about, we're going to try to do, once they get those NFPA standards finalized, we'll come back and help you guys understand where that's going to really play in for you and what you should have knowledge on and what you should know about advising people on what those standards are and what it means for them. But some places might have a stricter jurisdiction than others, but typically that insurance company is going to be the ones who have a lot to say about how things go in and what they do. Dave, is that your experience too?
Yeah, same thing. And a question for you, because we get asked this quite often. If we get a manufacturer or an owner, or even a contractor for that matter, that's in a facility, Donovan, that comes to us and says, hey, I'm being told by my mechanical or I'm being told by my engineer that I need to put these safeties on my dust collector. And they say they've been running like that forever, for 50 years with the same collector, and it's an explosive dust. First question would be, when did this take place? When did we actually say you need to put safeties on your dust collector? And how do you handle that when that question comes in?
Yeah, so there was a new law that's passed that requires everyone to have a DHA, and that's a dust hazard analysis. That's something that kept getting pushed back by the government, but it's finally in place. And that requires that someone who is an expert in the field, is what they call it, to evaluate the full scope of your dust in your facility. And that goes down to whether there's dust on the rafters, down to the actual collector that is in place. So that DHA is going to help dictate what safety precautions need to be put in place, even on old collectors. When you start to get into older collectors and you're talking about trying to make those safe, you're going to have to look at, is that actually rated for an explosion? A lot of these older collectors that are predate any of this, there just wasn't any testing done on them. So there are other engineering firms out there, there's companies out there that can come in and do a lot of calculation to tell you whether that collector is strong enough and how many vents would be needed to put onto an existing collector. With that, you're still kind of taking a little bit of a chance there on what is actually going to be safe, because with our collector, when you get a brand new collector, it's been tested. We know all the ratings. We've done that. And so when it goes out in the field new, you can have your dust test. You know how explosive the dust is. You can then make sure that you have a collector that is protected properly and sized properly when you start from scratch. When you get into older facilities, it gets tricky. And it might be that on a wood facility, they might need to have an abort gate, and they might need to have a one-way valve, the EIVs on that. But it's going to take, even though they haven't been doing it for the longest time, and they haven't had an incident, it doesn't mean they can't have one tomorrow. So I would say that, you know, I've never been in a car crash where I've had you know, detrimental damage to my body, but I'm gonna still wear my seatbelt on the way home because I never know what could happen tomorrow. So just because nothing's happened yet doesn't mean that we shouldn't still try to take as much safety and precaution as we can for the future.
Has anybody had any experience? We've got a mix of engineers and mechanicals both on the call and in person. Has anyone ran into this? Has anyone met an AHJ? Who dictates it on
Yeah.
dust collection side? Anybody?
It's funny, I called our insurance company a while ago. I'm like, hey, this dust hazard thing is kind of an issue. Would you like us to be available for your customers who need a dust hazard? They're like, we're good. Like, why aren't you guys in the, you know, like when I sign my insurance form, I have to like accept or decline all sorts of different types of insurances. And you would think, like, an insurance company, if they don't bring up a dust hazard, they're putting themselves at liability. But I just don't think that the insurance companies, at least the agents for sure, are insured. And maybe there's a gap between what the insurance companies know and what the agents know. But I was like, hey, you know, your clients, we go and see collectors all the time that are not safe. And they're just like, okay. I mean, maybe that's gonna change. But
It should.
but so far, not a lot of action. Not a lot of action there. So
Well, what they always say is when you walk out on a job, if you look at it, you should know better one way or the other, and you saw it. And say you're a PE, say you're an AHJ or a fire marshal, if you see an infraction of some type, it's mandatory that you're supposed to report it, right? Well, if you walk in the facility, you see it, and you do nothing about it, or you work for a company that's got an issue and you know it's an issue and you do nothing about it, lawyers are gonna go after everyone and anyone they can. They're just gonna start with the deepest pockets and work their way through. And then it becomes who has the deepest pockets to protect themselves, and more often times than not, it's not us.
Yeah. And also we just, you know, I know it's the heart of airflow, it's the heart of Imperial systems to just have a safe environment for workers. We want everybody to go home healthy and safe at the end of the day, you know, better than they were. And that's why we build these and try to build the best dust and fume collector on earth, because we want, you know, whoever's out there welding, whoever's out there working in that wood shop, whoever's doing that, to just go home healthy and safe to their family at night. And I know that's a lot of the people on this call, that's what they're trying to help design, is a good, safe system for those people that are out there working. So.
Is it possible to mix wood dust and metal dust?
Is it possible to mix wood dust and metal dust, or two dissimilar property dust going into a collector?
Yeah,
Say that.
I mean, you can. Those are you're kind of asking for some issues on that. A lot of the times, like when I'll see that is in like maybe a knife shop, places that build knives, because they'll have the dust collector where they're grinding the knife, and then they have a dust collector. They have the same one where they're working a handle, or they're using a resin over there to shape that. So I've talked to people in knife facilities. That's just one that came to the top of my head. You just need to make sure that when you're putting those all into the same collector, that it's sized properly, because it might take different types of things. A lot of times what we'll talk about too is when you get into some of those mixed materials, a Cyclone is a good option to help size and classify that prior to it getting to the final collector, that final filter, which could be a CMAX. So that's a good way to kind of help protect the collector and protect the filters at the time. But you can mix things, but you try to keep it separate if you can, but it's just not always a possibility. And so having someone who has the knowledge and experience of doing that before really helps on sizing that correctly. Because like I said, if you go to a book and it says this is the air cloth you need for wood dust and this is what you need for metal dust, you can't just kind of add them up, or you need someone who knows, has been in that scenario before to help you walk through that, to make sure you get the right air to cloth ratio and the right travel velocities in those ducts and the right safety precautions. Because when you're adding like a metal dust with the wood dust, that's a potential for a fire.
Yeah, and we try and keep them separate if you can, only because if you've got 10,000 CFM for wood dust that's explosive, and you want to add 5,000 CFM for weld fume of some type that may not be explosive, when you add that 5,000 of non-classified CFM coming into your collector that's already got to be classified, you now have 15,000 CFM of classified dust coming through there.
Right.
You can separate those, and all your safeties become less. I mean, these abort gates, when you go from 20-inch to 32-inch, they go up exponentially in size, weight, cost, install.
Yeah, and when you start to mix those dusts, you might have to go to a chemical suppression as opposed to a passive suppression, and that gets into a lot of money and annual fees on that. So can you do it? Yeah. Is it always the most economical and smartest way to do it? Not always. So, but sorry, Dave, keep going.
Oh, no, that's pretty much it. Do we have anything else online or in person? Any other questions? Everyone knows who to call now? Not Ghostbusters.
If questions come up after, go ahead.
Oh, you're good.
I say if questions come after this, or you guys think of something, please feel free to reach out to Airflow, reach out to Imperial. We have a lot of resources on our website. They have a lot of resources on their website as far as podcasts and white papers and just general knowledge if you need to get more into this, if you have a project that comes up. But I know Dave and those guys out at Airflow, they're more than glad to just, if you have a question, call them up, send them an email. They'll walk you through exactly what you need to do so that we get the right solutions in place.
And if anyone's online or even in person, I mean, in-person class, we're gonna head down and look at it after we have lunch. We'll look at our demo trailer. If there's anyone online that wants a visit with the demo trailer and we can bring it in, we can run you through it, kick the tires. You can actually see what an EIV does, look inside of it, see what an abort gate does, talk about the Rhino Drum, the collector, the filters. You can handle it, change filters, work the whole machine itself. So just let your salesperson or engineering group at Airflow know, and we'll get that trailer out to you.
Hey, how about a nice hand for Dave, Madsen, and Donovan?
All right. Well, thank you guys. I'm gonna sign off here so that you guys can go enjoy some snacks and see the demo trailer.
Thanks, Donovan.